1.1.1, we have x squared plus x minus 12, which is equals to 0. So we need to use factors in order to solve for this. This is x, this is x. The factors of 12 that when we add or subtract them will give us a 1x. It's going to be 4 and a 3. And this sign is taken by the number which is the biggest of the two. So that's going to be plus, that's going to be a minus. X should be equals to 3, or x should be equals to negative 4. So the minute that you see something like answers correct to 2 decimal places, it means that you need to use your quadratic formula. So it's going to be 3x squared minus 2x minus equals to 6. So we first need to write this in a standard form. 3x squared minus 2x minus 6 should be equals to 0. So we're going to use the quadratic formula, negative b plus minus b squared minus 4 over 2a. So our b is minus 2 plus minus 2 squared 4. Our a is 3 and our c is minus 6. 2 into 3. Then just going to use our calculator to find the solutions. So I'm getting x is equals to 1.79, or x negative 1.12. So 1.1.3. So 2x plus 1 equals to x minus 1. Whenever you have a square root like this, it's most likely that you need to square both sides and then simplify. So here we'll be left with 2x plus 1, which is equals to x squared minus 2x plus 1. So this is x squared minus 4x minus 0. So x minus 4. What I did here was just take out a common factor of x. It makes the work much easier. So x should be equals to 0, or x should be equals to 4. In most instances, when you have a square root, you need to check if the solutions that you have do indeed satisfy the equation. So let's check. The 0 is not going to, so 2 into, so that's a 1. If I put a 0 there and a minus 1, this is going to be negative 1. The other side is going to be 1, so it can't be 0. 4 plus 1, so it gives me a 3. If I put a 4 there, minus 1, it's going to be a 3. So x should be equals to 4. So x squared minus 3 should be greater than 2x. First step, standard form, always minus 3 should be greater than 0. So we need to find the factors x and x. The factors are going to be 3 and 1. So the middle sign is negative, so the bigger value will take the sign, and then that's going to be positive. That's greater than sign. So the critical values are going to be negative 1 and 3. So we're going to take any number that is less than negative 1 and plug it for the value of x there in C. So I'm going to choose negative 2 plus 1, negative 2 minus 3. So I'm getting a positive. For any number that I'm going to substitute for x there, I will always get a positive answer. Then I'm going to choose a number between negative 1 and 3. So I'm just going to choose 2. So I'm getting negative. The other side is going to be positive. So we are looking for the x values that when you substitute, they give you an answer that is greater than 0. So this is positive from here going that way. This is also true this side. So x must be less than negative 1 or x should be greater than 3. So we have x plus 2, which is equals to 2y. That's equation 1. And then we have 1 over x plus 1 over y is equals to 1, 2. So from 1, we know that x should be equals to 2y minus 2, which is going to be our equation 3. I simply just took the 2 and transposed it to the other side. So we are going to substitute 3 into 2. But before I do that, I just want to simplify this so that I don't make too many mistakes when I substitute. So y plus x should be equals to xy, which is equals to 1. So y plus x should be equals to xy. Y plus, you remember that x is equals to that. So it's 2y minus 2, which is equals to 2y minus 2 multiplied by y. This is 3y minus 2, which is 2y squared minus 2y. So 2y squared minus 5y, and it's 2y squared minus 5y plus 2, which is equals to 0. So we need to find the factors. So this is obviously going to be a 2y and a y. In order for me to get to there, I need to have a 2 there and a 1 there, so that becomes minus 4y and then minus 5. So this is going to be a 1 and that is going to be a 2. Since that is positive, it means that both of them are negative, which makes sense because this must be minus 4 minus 5 and that must be a positive 2. 1 over 2 y should be equals to 2. Then now you're going to substitute y into 3. You remember your 3 was that x should be equals to 2y minus 2. So we're going to substitute. So x should be equals to 2 into 1 over 2 minus 2. Or x should be equals to 2 into 2 minus 2. So for the first one, we are getting a negative 1. And for the second one, we are getting a 2. So technically, this is going to be negative 1 and 1 over 2. And the other one is going to be 2 and a 2. Let's check if this does indeed make sense. So we know that we have 1 over our x is -1 plus 1 over our y. Our y is a half. So yeah, I do get that one there. Even for the other one, so it's 1 over 2 plus 1 over 2, which is a 1. So both coordinates are correct. 1.3. So 2m plus 1 plus 2 should be equals to 3m plus 2 minus 3m. So here we need to apply the laws of exponents. So whenever we multiply powers of the same base, we add the exponents. So this means this was 2 to the exponent of 1. So that when we multiply powers of the same base, we're going to add the exponents. So this is exactly like that. 2 to the exponent of m. We're going to do the same thing even this side. Okay, I'm going to take out a common factor of 2 to the exponent of m, that is 2, and that plus 1. 3 to the exponent of n, that's going to be a 9 minus 1. So this is 2 to the exponent of m, 3, and then 3 to the exponent of n, 8. 2 to the exponent of 3. This we know that it is 2 to the exponent of 3. So this means that m should be equals to 3 and n should be equals to 1. Therefore, m plus n should be equals to 3 plus 1, which is equals to 4.